When you stand in front of a concave mirror, if you're far enough away, you see an upside-down image of yourself. Let's take a look at why that is. First, let's look at a side view. The concave is that shape, open to the viewer. Not only do you see an upside-down image of yourself, but to focus on the image, you actually have to focus in front of the mirror as it appears to be in front of the mirror. To understand why that is, we first have to look at the law of reflection. So let's take a flat mirrored surface and an incident light ray. Now, if we draw the normal to that point where the light ray strikes the mirror, the law of reflection tells us that the reflected ray, the angle that it makes with respect to the normal, will be equal to the angle of the incident ray. That is the law of reflection. Now, consider a curved mirror and the tangent to that point at the curve. As it turns out, the law of reflection still applies, and the ray will reflect as if there was a flat mirror aligned with that tangent. Take another ray as an example. So we reflect that ray, we have to draw a tangent and a normal, and draw the reflected ray with an angle, incident angle equaling reflected angle. Okay, so let's look at a spherical mirror. A mirror imagined as part of a circle with a radius. We'll call the midline that meets the vertical part of the mirror the optical axis. As it turns out, incoming parallel light to that optical axis will all be reflected, according to the law of reflection, through the same point, which we call focal point, or the focal length is defined from the mirror to that point. It is half the radius. There's another shortcut ray we can use to help us find images from circular concave mirrors, and that is usually the incoming light ray that hits the vertical part of the mirror is easy to spot the law of reflection. Another good one to use is light coming in through the focal point bounces out parallel. So it's the opposite of incoming parallel light. So we'll use some of those shortcut around the law of reflection rays to understand and locate the image from a concave mirror. Just take a look at that side view again. Mark our focal point. Let's take a light ray from the head, bounce it off, incoming parallel to the optical axis, back through the focal point. Now if we get another light ray from the head to intersect that, we'll have located the image of this man's head. Let's go through the focal point and out parallel, and we've located the image of his head. Now if we do a similar process with the feet, we can learn something about the orientation of the image. So let's go through the focal point and back out parallel. Let's go to the vertical part of the mirror and out according to the law of reflection, as if there was a vertical plane mirror there. And those two blue reflected rays intersect there, which make for the image of the feet. So we get an understanding then of why there is an image created of that man upside down, inverted, in front of the mirror.